Hello, this is Jacob,
And Anthony.
and this is our project 4 for operating systems. Here, let's show that our code passes all of the tests. So we did have to edit the makefile a little bit.
We added in the creating of the unit disk.image so that, the thing wouldn't fail because the file didn't exist.
Yeah, unit disk required a certain file to exist, and that file by default does not exist. So we had to add a single line to our makefile to make sure that was there.
And then as far as quirks, errata, or unresolved issues, we didn't have any errata. Our only quirk was an introduction of a cache.
Yeah, you can see that. You can see that here. Essentially, since loading inodes is such a common operation, in order to basically slash the amount of disk reads to 0, we cache the last inode block that was loaded. And so what this allows us to do is make accessing inodes a memory access rather than a disk access most of the time. Since usually you only have 2 inode blocks, you basically never have to go out to disk for inodes. So I know you said don't worry about efficiency, but it was an easy thing to add.
And then the only kind of unresolved issue, I guess is what I classify it as, is we weren't sure what to do about printing errors, for error checking. So for some of them, the ones that are more like programmer errors, we print out a standard error, what the issue is. For ones that are more like user errors, we just return the bad exit code. And then that brings us to our diagram that Jacob graciously made to help us explain what happens in the code segment given to us.
All right, so the code segment opens. The first non-trivial line of code is a open path.task read only. So this begins by consulting the inode table, which is a data structure located on disk. It looks up the path, which is path.text in this case, and checks if there's an inode relating to that path. If there isn't, it just returns an error. If there is, though, didn't mean to move that, it opens the entry of the inode table and reads the inode permissions, check if the inode permissions permit opening this file with reads. If not, it returns an error. Otherwise, it checks if there's free file descriptors on the system, since Linux has a maximum file descriptor limit. If there are free file descriptors, then it maps one of the unused file descriptors to the inode and stores this in a table of file descriptors to inodes. Then we enter a while loop, which opens the read function. Internally, the read function has a variable to track how many bytes it's read so far. It then checks the file descriptor offset, which is a value associated with each file descriptor, to check how many bytes, where in the file we should start reading from. If this offset is past the size of the file, then we can exit early. Let's assume that it's not for now, so we can get to this part of the diagram. We use the inode table to read the data block, which is located at offset bytes in the file. So it consults the inode with inode index, whatever the file descriptor maps to, and it checks what blocks it points to. This could be done through direct pointers, indirect. The data structure depends on the file system. However many bytes it read, it adds that to the offset. Then it essentially checks, should we keep reading or not, using a simple computation. So for the sake of time, let's assume that we've read exactly buffs' bytes and we could exit. Bytes read greater than 0, in this case it is, since we've read some number of bytes. We re-enter the read function. Let's say now the file offset is past the size of the file, so we go back to bytes read. Now it's 0 since we didn't read anything. We close the file descriptor, which essentially goes into the table and stops associating our inode to the file descriptor. So essentially, next time you try to use that file descriptor, it doesn't point to a valid inode anymore.
And then that leaves us with what we've learned for this project. Me personally, I learned Jacob was very nice to explain a lot of the inode table stuff and kind of how things function under the hood. So I learned about the fact that inode numbers you don't directly put into the direct pointers to try and access things. You have to actually read them first and whatnot. I also learned about logging files, as Jacob was talking about with our error messages. I also learned or was refreshed on how caches work from the implementation of our little efficiency boost. But
Yeah, I mean, I mainly learned about how to actually implement file systems. As always, you could talk all the theory you want, but until you start coding, you don't really understand what goes into creating it. And I guess I learned how surprisingly not that hard it is to create a simple file system. I'm sure real file systems are infinitely more complex, but I guess it is just data structures at the end of the day.
good old data structures.